like, I feel like we need to do it and I need to show it to you. So I'm not going to go through the steps. This is going to be one of the sections where we jump in and I'm going to show you how to do it. So the steps are there. You can look at those. But I think it's better to just do it than to explain it with steps. This is one of those sections for me. Like I said, some days you guys know I like to even highlight the steps so we know what words go along with what work. Yep, it's in the folder. Okay. So when you are doing synthetic division, the first thing you want to look at is what is being divided in. And you're going to want to solve that for when it would be 0. So the question is, when would x minus 2 equal 0? So what value of x would make this true? 2. All right. So I'm going to plug in 2 for my synthetic division. Here's how you set up your synthetic division. You're going to put a 2, and it's going to live in this little, I don't know, on a ledge kind of is where it lives. So put the 2 there. This is how we set it up. It's kind of hard to explain the first time, so use my words the best I can. Next, when you go to put in the next numbers, before you do anything else, remember we talked about the fact that it has to be in standard form, right, when we were doing long division? Is this in standard form?
Yes.
Am I missing any terms? No, because it goes 2, 1, and then nothing. So if you're missing terms, you need placeholders just like you did in long division. If it's not in standard form, you need to fix that just like in long division. Then you're going to take the coefficients only. So the 3, the -8, and the 4. So you're only taking the numbers. So I'm taking this 3, this -8, and this 4. And they are going here. I would put a little space in between, because if you have them right next to each other, then it might look like you're doing 3 minus 8. Or these two, if you smushed them together, might look like -84. So yeah, I definitely would leave a little bit of space in between them. All right, then I want you to leave about 1 line of space and give me a line. So again, the setup for this is a little funny, but trust me when I say it's easier. And then I want you to put an addition sign here, because truly we're going to be doing some like vertical adding, kind of like what you did probably all the way back in 2nd grade-ish. All right. Once you get it set up, so this is the setup. The setup is done. Once you get it set up, there are 2 steps the rest of the way through, and you just repeat them and repeat them and repeat them. And they have to go in this order. You're going to add, and then you're going to multiply. And then you're going to add, and then you're going to multiply, etc. So you're going to keep going. So step 1 is add, step 2 is multiply, and then you're going to just keep alternating between those 2 things. So getting it set up is half the battle. All right, here we go. So we add first. Do you see how there's a 3? Do you see how there's nothing underneath it? 3 plus nothing is 3. Anything that drops below this line gets multiplied by this number that's on the ledge. What do we know 3 times 2 is? 6. So to get here, I did 3 times 2. And then we're going to add again. What is -8 plus 6? -8 plus 6. -2. Anything that drops below gets multiplied by this. -2 times 2 is what? -4. And it moves up over here into the next spot. So I did -2 times 2. All right, and now I'm going to add down again. 4 plus -4 is 0. All right. Also, typically we put another little ledge right here under the very last thing. Is there anything more beyond those 4s? No. So I'm done and I landed on 0. So here's how the answer works. Whatever is on this ledge is your remainder. The next thing over is going to be your constant term. A constant term is when you have just a number. The next thing over is going to be your coefficient in front of x. And some of these are going to be bigger. So then the next thing over would be your coefficient for x squared and x cubed and so on. So the answer to this division problem is 3x minus 2. There was no remainder, so this is my answer. And if you don't trust that that's going to work, you can do long division to check it, and you should get the same thing. Or, remember, we can FOIL these two things back out, and we should get what we started with. So this is a much quicker way than doing the long division we were doing before. It takes a minute to get into this because it's a little bit different way of thinking. So if you are like, oh, I picked up like 30%, that's fine. Let's do some more, and then hopefully each time you're picking up a little bit more. Okay, remember this is saying divide me, right? Okay, so the first thing I'm going to do is think what would make x plus 2 equal to 0. What value of x would work? -2. So the first thing you do is you set that equal to 0 and think what would make it 0. That number goes on the ledge. So whatever that number is, and again, if it helps, you can kind of highlight to show where stuff went. Boom, boom, and there's that -2. All right, before I can do my next step, I'm going to take a look at this. Is it in standard form?
Yeah.
No. Well, yeah.
It's in standard form, but you're going to say but. What are you going to say but about?
There's a missing.
There is a missing term. What am I missing? Yes. So right here, in between the x cubed and the x, I have a 0x squared. That's not mentioned. So I'm going to just write myself a note and remind myself that, like, hey, self, you're missing a term. All right, let's find our coefficients next. My coefficient is 3. What's your coefficient here? -1. Now, the next coefficient is 0 for the missing term. Then, and then we draw our line and our plus sign, and there's always going to be a ledge under the last number, and that ledge, oops, you can't see that, let me move up a little, that ledge always holds your remainder, so that last bit there is always going to be your remainder. So I'm going to quickly go through and highlight one more time so we can see where all these numbers came from. So this went here, this went here, 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 and here. If the arrows help you, go ahead and draw that in for yourself. If that's too much and you're like, it's too busy and I can't figure it out, then don't add in the arrows and the colors and all the extra bonus things. Okay, we always add first. Add, multiply, add, multiply. 3 plus nothing is 3. Anything that drops below gets multiplied by this number. 3 times -2 is
-7. No. -6.
-6. So remember, 3 times -2, it moves up and over into this spot. What is -1 plus -6?
-7.
Now we're going to multiply again. -2 times -7 is,
14.
and then we're going to add down. 0 plus 14 is, and then we're going to multiply again. -2 times 14, -28, and then we're going to add down. I get -23, Negative 23 times negative 2 is 46. And negative 1 plus 46 is 45. So 45 is my remainder. This is my constant. This is my coefficient for x, my coefficient for x squared, my coefficient for x cubed, and if there were more, x to the fourth, x to the fifth, and so on. So here's how we write our answer. 3x cubed minus 7x squared plus 14x minus 23, that's my constant, plus the remainder. What should I put on the bottom of that fraction? Do you remember for the remainder? Yeah, this bit right here, if you have a remainder, goes on the bottom. Faster, do you agree, than the long division?
Arguable.
You could argue it. I think once you do it a couple times, I don't think you can argue it anymore. I think it's just faster. All right, we're going to do 2 more. Do you see why I said the list of steps doesn't really make sense? It's like one of those things you have to do, right? It's kind of like if somebody was trying to give me a tutorial on my cell phone. Like, I hate it when they switch up the cell phones and you've got different buttons to press for stuff. Like, I need somebody to just show me a couple times, right? Like, a list of steps is not going to help me. Like, just show me how to use it. So that's why that's what we're doing here. Just show me how. All right. So the only bummer is that you can only use synthetic division when you have x to the first as your, oh, you can't see that, sorry. When you have x to the first as your spot in the divisor. So if you had x squared or x cubed or something else, we can't divide using this method. So if you look back to those 2 examples that we just did, do you see how what we were dividing by was an x to the first and an x to the first? What I'm saying is if this had been an x squared or an x cubed, we would have had to use long division. So one of the reasons that some people like to stick with long division is because it always works. Okay? I'm not going to talk about this thus piece. We don't need that. But we do need this. So again, please know that the only way you can do synthetic division is if you have an x to the first. All right, let's do 2 more examples. These are going to be the same type of problems.
On the test, will we be tested on synthetic division, or is long division always most?
You can always use long division. So you don't have to ever use synthetic division. Because synthetic division is nice and it works, but only for certain situations. It's kind of almost like the quadratic formula. Like, I feel like the quadratic formula is almost the end-all be-all to me because you can't always factor and solve. Like, the always way is the long division way. So I'm okay if you always use long division. Okay, let's do 2 more of these. They're just set up differently to show you some of the different formats they could come in. Okay, so this is what you're dividing by. This bit right here. So the first thing we're going to do, just like we did on the others, is we're going to think, okay, what would make it 0? 2x minus 1, what would make it 0? So what should I do? How would you solve? Add the 1, right? So 2x equals 1, and then what? Huh? Divide by 2. Do we agree that x would be 1/2? So if it was 1/2, half of 2 is 1, 1 minus 1 is 0. So are we okay with the fact that it's 1/2? So 1/2, or 0.5, I don't care if you do fractions or decimals, this is not a spot where we care. So if you are more of a decimal person and you would like to write 0.5, go for it. That is not a concern here. All right, then let's look at the numerator, what we're dividing into. Is it in standard form?
Yes.
Yes, but, what's the but? Yeah, so I'm going to write 0x cubed to remind myself I'm missing a term. So in between the x to the fourth term and the x squared term, I'm missing an x cubed. So I could write that as 0x cubed as kind of like the placeholder idea. Let's go look at our coefficients. What's my coefficient for the first term? 4. What's my coefficient for x cubed? 0. What's my coefficient for x squared? X. And then my plain old number is 9. Draw your line, draw your addition, and put the ledge that holds your remainder. Like I said, the setup is truly half the battle. Do we have the setup? Do we feel a little bit better about it the more we do? Okay, add first. It's always add, then multiply. Don't ever switch that order on me. Add first. 4 plus nothing is 4. Anything that drops below the line gets multiplied by what's on this ledge. What is half of 4? 2. And then we add down again. 0 plus 2? 2. Half of 2. Add down. Negative 37 and 1 is? Yeah. What is half of negative 36? Ooh, 18, right? Negative 18? Oh, should be 18, right?
Yeah.
Okay. I was like, wait a second, is Miss Vessel having a moment? 2 18s should give me 36. Okay, 4 and negative 18. Negative 14. What's half of negative 14? Negative 7. And add one more time, I get negative, oh no, you're right, 2, just 2, positive 2 for my remainder. Okay, so 2 is my remainder, constant term, x, coefficient for x squared, coefficient for x cubed. Okay, I'm going to freeze my screen. You try writing out the final answer without me. I'm going to write my final answer and then I'm going to show it to you. So try just writing out the final answer, because that is truly another part of this battle. It's just once you get done kind of analyzing what you got and how do I write that down. Are you ready? I'm going to uncover mine, check and make sure yours looks like mine. Did we traverse that okay from what we got to our final answer? Yeah? Okay. Try part D without me at all. No help. Okay? Look at what you're dividing by. Think about what would make it 0. So I'm going to do it, you're going to do it, and then we're going to chat. So this one's a fraction too, which isn't my favorite. Remember, you could write it as a fraction or a decimal. Okay, you should be getting some zeros for some of the things that are below the addition bar. So if you're like, ooh, I'm getting zeros, that's okay. If there's no remainder, remember you don't have to write anything there for it. I'm going to give you another minute and I'm going to show you what I got and make sure we match. Again, trying to help us be just a little bit more independent each time we do this so we can eventually do them without me. Okay, ready? I'm gonna unfreeze. Do you see how for the 0x squared I didn't include it? Bless you, bless you. This is more of a question of how well you know me at this point. Would I mark you wrong if you put a plus 0x squared in here? No. Is it necessary? No. Is it hurting anybody? Also no. Is it wrong? Also no. All those questions are no. So you could put plus 0x squared and that is fine. If you want everybody accounted for, that's a-okay. You could even put plus 0 at the end over 4x plus 3. You could do that too and that would be fine. Alright, assignment number 6. Are you ready for homework already? Wait, no, 7. Just kidding, I lied. Assignment number 7. That's a really bad 7. Page 245 to 246. I'm going to double check these and make sure I want all of them. 11 through 20. So 245 to 246. So we're still in that same section that we were in. 11 through 20. I'm just making sure I don't have any that were randomly x squareds that jumped in. I don't. Okay. All right. So here are the problems. And then, of course, the next ones are on the next page. So I think what I'm going to do is freeze again. So do you see how you can see 11 through 16? And then I will write 17, 18, 19, and 20 on the whiteboard.